Here, 1 second. Let me pull them up.
Okay. Were these all online?
Yeah, but I don't have them on me. I forgot. I just realized I forgot them. But I can, it's like, when you have, I could try to think of an example because I still remember class today. It's like, for the multiplication, you had to distribute into, it's hard to explain.
It's easier if you have a problem that you
Yeah,
can give
definitely.
me, and then we can go through it and solve it. So you're doing multiplying polynomials, adding polynomials, subtracting polynomials, and dividing polynomials?
Yeah, and when you add up the exponents, that's the you add up the exponent.
That's the rules of exponents.
Yeah.
Let's tackle
Okay.
one subject at a time.
Okay.
Here we're multiplying a binomial by a trinomial.
Yeah, that's what we did.
How do you do that? What's the first term? Just work me through it term by term.
Okay, so you distribute the x, so it's it would be x cubed plus 2x squared plus 3x. And then you distribute the 3, and you'd get 3x
Plus 3x squared.
plus 3x squared plus 6x plus 9.
Okay. Notice one thing about this. You only have one of those terms, and you only have one of those terms. All
you gotta combine the
middle can be combined. So we don't have to search for any more x cubes. We know we only have one of those. How many x squareds do we have in sum?
5x squared.
How many x's do we have in sum?
9x squared. I mean x, 9x, just 9x.
Again, plus.
Plus, yeah.
The plus is vital because this is part of a polynomial. And if I don't write a sign in front of that, it actually has no meaning. If I left it like that, nobody would know what I was talking about. Okay? So the plus is not assumed when it's part of a polynomial. You have to put it in. Okay?
Yep.
So that's multiplying polynomials. If you had 3 terms, a trinomial times a trinomial, then you would just do every term times every term, just exactly as you did with this. Okay?
It would take a while.
Dividing, it does, and the secret to that is just be very methodical. In other words, don't jump around. In other words, don't do that times that, and then that times that, and let's see, go back and do that. You see how you could get really confused and lose track of what you've done and what you haven't done. So always take the first term, multiply it by every other term, and then take the second term and multiply it by every other term. If you had 3 terms, same type pattern. Now, a little more difficult is dividing. If I divide x minus 2 into x squared minus 5x plus 6, that's dividing a trinomial by a binomial. Do you know how to do this using long division?
Yeah, I think so. So it'd be, you put the x minus 2 under the x squared minus 5, and you'd subtract them, so it would be...
Well, hold it. Let's do it step by step. First of all, we take that term and divide it into that term.
Yeah.
That's
Yeah.
step 1. That gives us x. Then we
Okay.
multiply the x by both terms. Now we subtract, because with long division you're always subtracting. So we get minus
Okay.
3x there, bring down the next term, plus 6, divide again, that x into that is always the first step. And that gives you minus 3. Multiply that minus 3 by both terms, and then subtract, and you get a 0 remainder. And the fact that you get a 0 remainder means that that is a factor of the quadratic.
Uh-huh.
If I got a remainder of 1, it would mean that x minus 2 was not a factor of this quadratic. There's something called the zero remainder theorem, which says that if a linear factor is a factor of a polynomial, then when you divide it, it has to produce a 0 remainder. Anything other than that, you don't have that. And that kind of leads into synthetic division. Have you had synthetic division?
Yeah, we did it last time.
Okay, you and I did?
Yeah.
Okay. So synthetic division is kind of a quicker way of doing long division.
Uh-huh.
Instead of turning it into subtraction, everything becomes addition, and it's just much quicker to do it when you're adding rather than subtracting.
Mm-hmm.
All right. Sounds like you've also covered this. What's x cubed times x squared?
X to the 5th.
What's x cubed divided by x squared?
X to the first. Just X.
And what's x cubed raised to the 2 power?
X to the 5th.
X to the 6th.
Oh, to the 6th. Okay, you multiply when it's like that. Okay.
Always remember it can't be the same as multiplication. The way I remember these is that you do with the exponents one level less than you're doing with the base. In other words, in this first one, I'm multiplying the x's, so I'm going to add the exponents. Addition is one level less than multiplication. The second one, I'm dividing the bases, therefore I'm going to subtract the exponents. Subtraction being one level less than division. And the third one, I call it double exponentiation, which really is what it is. You're exponentiating the x and then you're squaring that result. So to me, that's double exponentiation. But one level less than that is multiplication.
Yeah.
And
I get it.
that it couldn't be addition, because if it was addition, that means that would be the same as that. And you know that cannot be true.
Yeah, I was a little confused. I'd never seen that before.
Okay. So those are kind of two pretty different subjects, exponents and polynomials. Do you have some other problems you can give me that we can work on? Because I'm not real clear as to exactly where you're at.
Well, there's also the subtracting polynomials, I guess, but that's pretty much the same thing as adding, except it usually ends up negative.
Yeah, in other words, you can only subtract like terms, right?
Yeah.
So if I had this, and I'm going to subtract the following polynomial,
Yeah.
well, first term is 6x cubed, because it's 6x cubed minus 0.
Mm-hmm.
Second term is minus x squared minus 2x squared. That's minus 3x squared.
Yeah.
Third term is plus x. fourth term is plus 19. In
Oh
other
yeah,
words,
because you negative and negative.
yeah,
Okay.
subtracting and adding polynomials is really a piece of cake. You just
Yeah.
have to make sure that you only add and subtract like terms. In other words, there's no adding x cubed to x squared. You can't do that.
Yeah.
I
I
can
get it.
multiply them, but I can't add them.
Mm-hmm.
Interestingly enough, these are a lot like fractions. It's far easier to multiply fractions than it is to add them, right?
Yeah.
Whereas if
Because
I
when you add them, you got to make the
multiply,
denominator.
yeah, if I multiply 1/3 time or 1/4 times 2/3, piece of cake. 2/12 reduces to 1/6. But if I want to add 1/4 to 2/3, now I got this long involved finding a least common denominator in order to do it. And it's a much tougher problem. And division is easy with fractions. If I'm dividing 1/4 by 2/3, it's easy because I'm going to turn it into a multiplication problem. It's going to be 1/4 times 3/2. And then you just multiply numerators, multiply denominators. So in most math, multiplication and division is clearly easier than addition and subtraction, and same way with polynomials. Well, maybe not the same way. Actually, now that I think about it, with polynomials, it's actually easier to add and subtract than it is to multiply.
Yeah.
Because you don't have to do term by term. But, all right. So what other stuff? So
We could go over, I guess, a synthetic division just in case I'm missing something.
okay, let's take that original problem that I gave you,
Okay.
and let's do it synthetically instead of by
Let me see if I can figure
division.
out the
Okay,
thing.
so if I'm going to do this synthetically, I need a number. What are the coefficients across the top? First of all, what goes in the box?
The box is -2.
No, the box is
No?
0.
A 0?
Oh, no, the box is the 0.
Oh,
If
the 0.
that is the linear factor, then 2 is the 0.
Oh, yeah, yeah. Okay.
It's x
Yeah, you flip the
minus
sign.
has to equal 0, which means x equals 2. So what goes in the box is the 0. Notice that it usually has the opposite sign of this.
Yeah. If it's a factor, yeah.
And that's going to allow us to do everything with addition instead of subtraction. That's basically the difference between long division and synthetic division. Is you change the sign. The variables don't really mean anything. In other words, they just kind of go along for the ride. What's important is the coefficients and the numbers. So what goes across the top?
1, 5, -5, and then 6, plus 6.
And then how do you do that?
So you put the 2 below the 1 and
Actually,
add.
you always bring down this term as the first step, all the way to there.
Oh, you bring it down before you...
All the way, before you incorporate this number right here.
Yeah, okay, yeah.
Now you...
So bring it down, then you multiply that with the original term, the 2, and then you put that under the -5, you add them up, so it would be -3 times 2, which is -6, put that below 6, and then add them and you get 0, and that means it's a factor.
Which means my two factors are x minus 2, and what's the other one? Based on my answer here. In other words, your answer that you get, this answer right here, is the other factor.
So x squared...
No, x minus 3.
Minus 3. Okay.
Always remember that when you divide by a linear term, you're going to knock this down by 1 degree. So it's going to
Okay.
go from a quadratic to a linear term.
Okay.
Okay. Now, let's just cover one other situation that can throw people a little bit for a loop. And that's this, where suppose I had this. Now, whether you're dividing by long division or synthetic division, you have to do something here. And it is to add a dummy variable for x squared.
Yeah.
In other words, this is missing an x squared term. So if I was doing long division, I would have to write it x cubed plus 0x squared minus x minus 6. And if I'm doing it synthetically, I have to do the same thing.
You just have to add 0.
Yeah, I have to put that 0 in there. So across the top would be 1, 0, minus 1, minus 6.
Yeah, okay.
And now what's going to be left on the bottom is going to be a quadratic. In other words, I'm dividing a cubic by a linear. So the first term I get, let's just do this real quick.
Yeah. So 2, 4.
How about that? I made this up out of thin air.
And it actually ended up being a...
And it ended up being a perfect 0. Which means, what are my two factors?
It would be 1 plus 2, or x minus 2.
No.
And then
x. What do these three things indicate? What's that factor? It's x squared plus...
Okay, x squared plus 2x plus 3. Okay.
And that's it.
You just put it
now,
okay. Yeah.
That is an irreducible quadratic. In other words, I cannot factor that. And it produces only imaginary solutions. So usually when you are dividing a cubic by something and you get it down to two factors, one of which you want to factor it all the way down to linear factors if you can. But if this produces only imaginary, then you leave it as a quadratic. Okay? And notice how I started with a cubic. One of my factors is a quadratic. Had I started with a quartic, then this would be a cubic.
Yeah.
You knock it down by 1. Unless I'm dividing by x squared. If I'm dividing x squared into x cubed, then I'm going to have a linear term here.
Yeah.
Okay. So, all right. And the reason synthetic division is so valuable, unless you have something else specific, is that, let's say I have the following cubic. Okay? There is no easy way to factor this. There's no easy, if you did not have a calculator, this would be extremely difficult to factor. And there's something called the rational factor theorem. Have you gotten to that? P over Q?
No.
Well, the normal way I would factor this would be if there's a rational factor, it's going to take the form P over Q, where P are all of the factors of my constant, which are plus or minus 5 and plus or minus 1. And Q are all of the factors of the coefficient of the largest term, which is plus or minus 2, plus or minus 1. Now I take all combinations. That's a possible answer. That's a possible answer. That's a possible answer. And that is a possible answer, which gives me plus or minus 5 halves, plus or minus 5 plus or minus 1/2 and plus or minus 1. So what my theorem says is that one of those 8 numbers has to be my 0.
Uh-huh.
And it's a trial and error process after that.
Yeah, you gotta just keep on doing it. Yeah, you told me
Well,
that.
you have to just pick one and use synthetic division because that's the quickest way to do it. So I always start with 1. And across the top, I'm going to have 2 minus 1, 4 minus 5. And I'm going to keep trying these things until I produce a 0 remainder. Well, let's see what we get here. Wow, amazing.
For sure.
I can't believe that. Somewhere in my subconscious, these things must lie. Because, yeah, this is totally accidental. Okay, that tells me 1 is a 0, which tells me x minus 1 is a factor. What's my other factor?
X, wait, X, no, wait, 2x, no, 2x squared plus 1x, or just plus x, plus 5.
If I multiply that times that, I will get what I started with.
Okay.
And had 1 not worked, then I would have tried
Right.
minus 1. And if that didn't work, I would have probably tried plus 1/2 and then minus 1/2 and then plus 5 and then minus 5. I would have tried all 8 possibilities until I produced this magic 0. Because it's only when you get a 0 remainder that you have found the factor.
Uh-huh.
Okay? So that might not be something you've gotten to yet, but this you're going to get to this eventually. I don't know when, but I kind of hate to get ahead of you, especially when you have a final tomorrow. So it really is going to work much better if you give me some problems that we can tackle. And obviously you want to give me problems that you aren't certain that you know how to do, rather than if you're certain you know how to do all of them, then you're going to be in really good shape for the final.
Well, I have 2 more things.
Okay.
The triangle, I forgot the name, but it's a named triangle. It's like a...
Isosceles triangle, equilateral triangle.
No, it's some kind of way of factoring where you can you can just keep on going down and down. It's hard to explain. On the edges always end up being 1s, and then the middle ones are always like factors of a number.
I'm talking about Pascal's triangle.
Yeah, Pascal's triangle, that one. I don't know.
Triangle. It's not really a triangle. It's like you said. And then the edges are always 1, but then the next number is the sum of the 2 numbers above it.
Yeah.
Okay, now I got a 1 there, now a 3 here, and a 3 there, and
then a 1.
And then
you get a
1,
6 in the middle,
and a 4, and a 6, and a 4, and a 1, and I could go on forever. Okay? And,
can you just remind me what that's used for again?
Well, it's used for a number of things, believe it or not. It looks like just a numerical oddity, and it really doesn't have anything to do with triangles.
Yeah.
But if you are expanding a plus b to some power, if you say this is going to be the coefficients of a plus b squared, this is going to be the coefficients of a plus b cubed. So this is really part of the binomial expansion. Notice that we're taking a binomial and we're taking it to some power. So if I had a plus b squared, my answer would be a squared plus 2ab plus b squared. If I had a plus b cubed, my answer is a cubed plus 3a squared b plus 3ab squared plus b cubed. So this Pascal's triangle ends up being the coefficients for when you take a binomial and expand it. So if I wanted to know what was a plus b to the 17th power,
You'd have to go down all the way to 17.
I would go to the 18th row of Pascal's triangle. And it's just not for a plus b. What if I had 2x plus 3y that I wanted to square? Well, I know that it's that, but a is 2x. So 2x squared would be actually 4x squared. And then 2 times a times b is 12xy. And then b squared is 9y squared. Okay? So no matter what your binomial is, even if it's a complicated expression, you can use this binomial expansion and Pascal's triangle to figure out all of these coefficients.
Okay.
So there's probably many other uses for Pascal's triangle. That's the only one I can think of right off the top of my head.
Okay.
But
yeah, I think that's what we're using it for anyway. So
yeah, it probably is. They tend to teach you Pascal's triangle and the binomial distribution at the same time. The binomial distribution can actually be very complicated to understand, but it's a lot easier if you understand Pascal's triangle. Because then you can always figure out which coefficients apply depending on which row of Pascal's triangle you're on. Although it actually becomes easier than that. Have you had combinatorics? Have you had combinations and permutations yet?
no.
Because they also tend to go with this. In other words, each of these spots in Pascal's triangle can actually be written as a combination. 6 choose 3 or 5 pick 4, which come into play in probability big time. And so Pascal's triangle, the binomial distribution, and probability all kind of interrelated with Pascal's triangle.
Okay. Can we do one more long division just to make sure? I'm a little confused about it.
Sure. What do you got?
Just anything. I mean, even the first problem over again would be fine because I was a little bit weirded out by it.
I'll make one up. And usually you're not dividing by a quadratic. You're almost always dividing by a linear term like that.
Yeah.
Okay. Now maybe you're dividing into a cubic. I'll make it a cubic this time. All right. What's the first step?
So you said the first step is to multiply.
Well, no, the first step is to divide that term into that.
Oh, yeah. Divide x into 2x squared, and that would be
cubed.
Yeah.
What do you get?
So it would be 2x squared.
Okay. Now multiply that 2x squared by both terms.
By both 2x cubed and x?
Oh,
no, 2x.
That,
2x.
Multiply it by that.
Yeah, okay. Yeah, so you'd bring, and then you'd bring those down. So it'd be 2x cubed under 2x cubed, and then it'd be 10x squared under
minus
x.
Minus 10x.
Minus 10x, sorry.
Don't drop negative signs. If you get in a habit of dropping negative signs, you'll always get the problem wrong.
I don't drop it in my head. I just drop it like when I say it out loud usually.
We talk about it? Okay. Well,
Okay.
one of the nice advantages of online tutoring is that it kind of forces you to verbalize your answers, and trust me, that's going to be good for you. In other words, you said you don't drop it in your head, which is great. You won't miss it on the test, but that'll get reinforced if you have to verbalize it also. Now you
Yeah.
subtract, and this is always going to be 0, first term, right? I mean, by definition. And then what's minus x squared minus a minus 10x squared?
Let me think. 9?
Positive,
9x squared?
positive
Positive 9x squared.
9x squared, correct. Now bring down the next term always.
So plus 4. And then
plus
plus 4x, yeah.
And then repeat. In other words, everything you did to start, do again. Divide x into 9x
into 9x squared. So it would be 9x, just 9x. And then you take 9x times x, and it'd be 9x squared under the 9x squared, and then you take 9x times 5, and it'd be 45x.
Yeah, now
negative 45.
Subtract that, you get a remainder. Well, not a remainder. There's still more. In other words, you can still do it one more time. Dominic, I am going to have to run. I forgot I have a 5:30 that I'm 2 minutes late at the moment. So
I'm sorry. Yeah, that's okay.
Okay. No problem. My mistake. But then you'd repeat it one last time. And if you have a remainder, then you have a remainder, but it would mean that's not a factor of that cubic unless your remainder is 0.
Exactly, yeah. Just like in a
yes,
synthetic.
Exactly. Just exactly like synthetic. Synthetic will give you the same answer as long division. It's just a little easier because you're always adding instead of subtracting. Notice how hard it was to subtract negative 10x squared from minus x squared. If that was an addition problem instead, it wouldn't be so hard. So, all right.
Okay, well,
I will talk to you next time.
Yep, I'll book it next time I need you, okay?
Sounds good. Bye-bye.
Yep.